Alright guys, so we're back, and another term that we need to get of understood is what is called electrolytes. I've seen questions on this topic, okay, and before I even explain what an electrolyte is, you people are going to encounter certain questions that will ask you to, for example, I may have iron in a solid state, then if I have this iron again in a molten state, they're going to ask me to say, why would be that this one can't conduct electricity, but when I have this compound in a molten state, it's going to conduct electricity? The reason that you have to give is that when a substance is in its solid state, it means that the ions are not mobile, meaning they are attracted to each other. There's that attraction still in that solid substance there. But when a substance is in a molten state, what it means is that the ions are free. They can move. Meaning, if I say ions, I'm talking about a cation, which is a positive, and an ion, which is a negative. So in a molten state is a state where a solution is like in form of a porridge. We know what porridge is. So in that state, the substance is going, or is that solution will conduct electricity because the ions becomes free. They're decollized, in other words. But in a solid state, they are attracted to each other. They are not free. They are not free. So that's why when a compound or a substance is, or when a solution is in a molten state, it's going to conduct electricity. It's all about the mobility of the ions, positive and negative. That's what will make that solution to conduct electricity. Now, since we're talking about electricity here, and this will only happen when an ionic substance dissolves in water. And once it dissolves, what else I said? The ions will be what? Will be separated. Now, we have three types of solutions based on how they dissociate into water. And to introduce that, we talk about what is called electrolytes. So what is an electrolyte? An electrolyte is a substance. It is a substance that dissociates. Dissociate is a process of splitting the ionic substance into its individual ions. That's we are dissociating. You have ionic substance, but we separate it into its individual. So dissociation and hydration, they move hand, like they work hand in hand. So a substance that dissociates into ions when dissolved in water. That is an electrolyte. Now, according to the name electrolyte, right, it's going to dissociate into ions when dissolved in water. This means that electrolytes should what? Electrolytes conduct electricity. They conduct electricity, and it decomposes in the process. They also composes in the what? In the process. That's what you are saying. So we are here. What we're trying to say is that when a substance can dissociate into the ions when dissolves in water, it means that there's a potential of that substance to conduct electricity, and that it's been composed in the what? In the process. So most of the ionic substances are what? Tend to be electrolytes, guys. You have to take note of that. So what I'm trying to say is that most of the ionic substances, right? So ionic substances tend to be what? Tend to be electrolytes. Ionic, because we know what an ionic substance is. So we can have that substance dissociates and dissolves where the ions becomes free. Now, most of the molecular compounds are not electrolytes, okay? Molecular compounds, if I say molecular, meaning there are no ions associated with this one. Remember, for it to be an electrolyte, should decompose into its ions, and that it has a potential to conduct electricity. So molecular ones For example, sugar can dissolve in water, right? Exactly, but do you know that sugar doesn't decompose into its ions? So that's what we mean. For example, even ethanol. You can have ethanol, right? It can dissolve in water, right? But does it dissociate into its ions? No. So those are molecular compounds. So we're saying molecular compounds are tend not to be what? Electrolytes. So meaning those are called non-electrolytes. Yes, they can dissolve, but they can't dissociate into ions. An electrolyte, for a substance to be called an electrolyte, what should happen? It must dissociate into the ions and that it dissolves. Then that is an electrolyte, and that it has a potential of conducting electricity, because once it dissociates, it means that the ions will become free, and anything, electricity can be what? Can be conducted. So guys, to categorize electrolytes, number one, we have what is called a strong electrolytes. We have strong electrolytes. So strong electrolytes, they dissociate. So these dissociates, they are strong. So meaning they dissociate completely. They are strong. So meaning they dissociate completely when dissolved. When dissolved in what? In water. So those are called the strong electrolytes. So they have to dissociate completely when they dissolve in water. And what means is that here you're going to find main ions. Why main ions? Because that ionic substance has dissociated like completely, meaning all the ions are separated. And what this means, it means that strong electrolytes will conduct electricity very well, because all the ions are free, all the ions are mobile, all ions are delocalized. So strong electrolytes will conduct electricity very well, and you're going to find the main ions because there's a complete dissociation of a substance. Now another category is what is called weak. Okay, so strong, they will dissociate and completely, as well as when they dissolve in water. What about weak? What about weak electrolytes? According to the name weak, it means that they will only dissociate partially. So only dissociates partially. What we mean by partial, meaning it's not all the ions that are separated. Some remain while attached to each other. So those are weak electrolytes. And to give examples, let me just get back to this first one. To give examples of strong electrolytes, you always have to go to strong acids, the ones you learned in your high schools, people. Strong acids, strong bases, and all ionic substances. Those are called the strong electrolytes. So now, weak electrolytes, saying they only dissociate what? Partially. So partially when dissolved, yes, they will dissolve in water. When dissolved in water, they will dissolve, yes. But what matters is them dissociating. So this is partially dissociation, meaning some will remain, some will be separated, dissolved in water. These are weak electrons, meaning what are going to expect here? There will be few ions. And yes, of course, they'll conduct electricity, but not as strong as the strong electrolytes. So few ions. There's a reason for few ions. Why? Because dissociation was just partial, it wasn't complete. So even when it comes to the behavior of conducting electricity, it will be slightly. And if they ask about examples of weak electrolytes, you guys, as long as you pass through grade 11, you pass through grade 12, you learned about strong bases, strong acids, weak bases, and weak acids. So give examples of weak acids here. Give examples of weak bases and weak electrolytes. Those things will dissociate partially even if they dissolve in water. The last category is what is called non-electrolytes. Non-electrolytes. So if we say these are non-electrolytes, what are we talking about? So what I'm saying is that these substances, yes, may dissolve, right? They may dissolve. They may dissolve in water. All right, but it does not dissociate into the ions. So there is no dissociation into the ions, you guys. it will just dissolve in water, right? But no ions will be dissociated. The examples that we talk about here, and I've seen questions asking you normally to give on the non-electrolytes. So these, yes, they will dissolve in water, right? Which is a solvent, but they won't dissociate into the ions. What examples do we talk about here? So examples, we talk about ethanol, as I've said. Ethanol will dissolve in water, but it won't dissociate into the ions. Let's talk about the behavior of sugar. Sugar will dissolve in water, exactly. But does it dissociate into the ions? It doesn't, so it is a non-electrolyte. For a substance to be called an electrolyte, it must dissociate into the ions and dissolve. The absence of dissolution or maybe the dissociation, then that is not an electrolyte. So this is the behavior of the non-electrolytes. They will dissolve in water, exactly, but dissociation of the ions, there's no. And normally we talk about the molecular compounds here, the molecular ones. For example, ethanol, sugar. What else do we talk about? Benzene. What else do we talk about? Urea. What else do we talk about here? Add more, find out other examples of non-electrolytes. All I know is that they're going to give you to say, given that ethanol and sugar are non-electrolytes, give any other 3 examples of that. So we have to explore more on this and find out. So guys, this is about electrolytes. Of course, questions will come even about the conduction of electricity to conclude this. So a substance will only conduct electricity when it dissolves, and that when it dissolves, the ions are separated. So meaning when the ions are separated, what I'm trying to say? What I'm trying to say is that those ions are free. So meaning they can be attracted to whatever that is being introduced in water. This is why even the behavior of water, there's what is called distilled water and salt water. Okay? So I'm going to find out when you have salt water, distilled water, what happens if I had to ask you? So I'm going to find that one can conduct, then the other one, there will be other, meaning the presence of the ions. What makes even water to conduct electricity? You people, sometimes water cannot conduct electricity, then some can conduct electricity. The reason is that when the ions of those, remember water is made of a lot of ions. There are a lot of their calcium ions, there are a lot of their nitrates there. So when those things are present, what will happen? Of course, automatically water will conduct electricity. It will become a good conductor of that because of the presence of those ions there. They have negative and positive charges in water there. So it will conduct what? Electricity. But if you can purify water, we remove all the ions using the nanotechnology and everything that we can apply, nanomembranes, to remove all the ions. What will happen? We can have pure water and it can't conduct electricity because all the ions have been removed. So that's all about electricity. So in my next video, we are going to talk about types of reactions, guys. What type of reactions takes place in aqueous solutions, redox reactions, precipitation, and neutralization.